Let's talk linear systems in 3 variables. So again, if we have 3 variables, we're going to have 3 equations. But don't let that overwhelm you. We're going to be able to deal with this in a very similar manner to the way we were able to deal with equations of 2 variables. So what we want to do here is eliminate one variable from 2 equations. So if we have 3 equations with 3 variables, if we eliminate the same variable from 2 of those equations, we've got 2 equations with the same 2 variables. So we have a system of 2 variables. We solve the smaller system and then we can substitute to find the 3rd variable. So this is nice because we get to use the elimination method that we just talked about. So we're going to use the same type of process there. So let's take a look at one of these. All right, let's say I'm looking at the system x minus 2y plus 3z equals 1, x plus 2y minus z equals 13, and 3x plus 2y minus 5z equals 3. What are we set up to eliminate? What would be easiest for us to eliminate? Remember, in order to use elimination, we have to have the same coefficient with opposite signs. It looks like we're set up to eliminate y here, right? If we add this equation to this equation, the y's are going to cancel here. And if we add this equation to this equation, the y's are going to cancel here. So we're set up to eliminate y. So let's do that here. So first equation, x minus 2y plus 3z equals 1, and x plus 2y minus z equals 13. We add these guys up, we get 2x plus 0 plus 2z equals 14. Can do the same thing for the last equation. We've got 3x plus 2y minus z equals minus 5z equals 3. We add these guys together, we get 4x plus 0 minus 2z equals 4. Now we have a 2-variable system, that new two variable system is this guy and this guy. So we've got 2x plus 2z equals 14, and 4x minus 2z equals 4. Now, we can solve this system using whichever method we want. We can either use elimination or substitution. But what's up with this? What would be easier here? We're already set up to eliminate z. Already set up to eliminate z. So let's go ahead and do that. So we add this first column, we get 6x. We add this second column, we get 0, right? That's the elimination. We add this third column, we get 18. 6x equals 18 means that x is just 3. Remember, we are solving this two variable system first. So now that we have one variable from the two variable system, we have to find the other variable from this two variable system. So we have to plug this into one of these. If we plug it into one of these, we'll still have two variables left, and that won't really be helping us much. So plug into two variable equation. We can pick whichever one we want. I'll pick this one because it's got smaller x coefficient. So 2x plus 2z equals 14. We plug it in, we get 2 times 3 plus 2 times z equals 14. So we've got 6 plus 2z is 14. So 2z equals 8. So z is 4. So now we've got 3 and 4. We can plug this into one of our 3 variable equations and we'll have our y value. We can solve for y. I'm going to plug it into the first one. So x is 3. Let's replace that one. Let's substitute there. Minus 2y, we don't know what y is yet. And we know that z is 4. So I've got 3 minus 2y plus 12 equals 1. I bring both of these over, so I'm subtracting 1 minus 3, so negative 2, minus 12, so negative 14. I have negative 2y equals negative 14, so y is 7. The answer to this 3 variable system is x, which is 3, y, which is 7, and z, which is 4. All right, let's look at this one here in the lab manual. So which variable here makes sense for us to eliminate? We've already got one variable eliminated from this last one. It's y, right? Y is eliminated from the last one. So let's just eliminate y from these up here. So if I've got positive 1 coefficient for both, I just need to multiply one of them by negative 1 and we're good to go. So I'm going to just choose this second one just because. So I've got 2x plus y minus z equals negative 8. This second equation is going to become x minus y minus z equals negative 3. I add, I get 3x plus 0 minus 2z equals negative 11. Now I've got my new system of two equations, right? The first one being this guy, so negative 2x plus 4z equals 18, and my second one being 3x minus 2z equals negative 11. Which of these variables would be easier for us to eliminate? Probably not these, right? Because 2 and 3, as we saw earlier, we would have to multiply both equations by something, which is more work than we need to do. Because, right, if we just multiply the second equation by 2, we'll have positive 4z and negative 4z. So let's just multiply this guy by 2. So we've got negative 2x plus 4z equals 18. We've got 6x minus 4z equals negative 22. We add these together, we get 4x plus 0 equals negative 4. So x is negative 1. We can go ahead and plug this into one of our equations of two variables. So I'm going to plug it into this one. So I get 4z equals 16, so z is 4. So I've got x equals negative 1, z equals 4. I've got 2 out of my 3 variables. So let's use these guys in one of our 3 variable equations and find y. So I'm going to use this one. So negative x plus y plus z equals 3. We want this guy to come in here. We want this guy to come in here. We've got negative 1 plus y plus 4 equals 3. Negative 1 is just positive 1, so we've got y. Positive 1, positive 4 is 5 equals 3. So y is negative 2. So my full answer is x, y, z equals negative 1, negative 2, and 4. All right, let's do one like this. So example, let's say we've got x plus z is 5. We've got y plus z is 7. And we've got x plus y is 0. All of these equations have 2 variables, but we don't have 2 equations with the same 2 variables. So we don't have a 2-variable system. So what can we do here? Well, let's just keep trying and see what happens. So normally we know that we want to try and eliminate one variable in multiple equations. So we know we're missing the y in this first one. So let's eliminate the y in one of these guys. So let's try eliminating y. So we've got y plus z equals 7. Let's multiply this second equation by negative 1, so we have the same coefficients with opposite values. So negative x minus y equals, well, negative 0 is just 0 still. Let's add these together. looks like we've got negative x plus 0 plus z equals 7. So we got rid of the y, but we gained a z, which is okay, right? Now we have this equation with two variables, x and z, and this equation with two variables, x and z. So we gather those together. We gather this one as well. And we solve this guy. What solution method should we use? Well, we've got positive x and negative x here. Seems like it lends itself pretty well to elimination. So let's add these guys together. We get 2z equals 12. So z is 6. All right, let's plug 6 back into one of these two variable equations. X plus z equals 5. So, but we know that z is 6, so x plus 6 equals 5. So x is negative 1. Now that we know negative 1, now we can plug either of these into one of the equations that has y to find y, and they should both give us the same thing. We only need to do one though. Let's use z again. So we know that y plus z is 7, and again we know that z is 6, so we know that y is positive 1. So the solution here is x, y, z equals negative 1, positive 1, and 6. Let's say we have something like this. So we've got x eliminated in this first one. Let's just eliminate x over here. We've already got opposite signs. Let's try and eliminate x here. I already have opposite signs. How can we make this negative 2x? Well, we just have to multiply by 2. So I've got 2x plus 3y equals 2. And I've got negative 2x minus 4y plus 2z equals negative 2. So I end up with 0x minus y plus 2z equals 0. All right, let's write our new system of two variables. So my first equation was y minus 2z equals 0. My second equation is negative y plus 2z equals 0. If I add these together, we're already set up for elimination. If I add these together, I get 0, 0, and 0. This is another one of those infinitely many solutions situations, right? So we have to figure out what these solutions look like in terms of something. Question that's like this in WebAssign, it asks for you to express it in terms of z, so that's what we'll do here. So we need to find everything in terms of z. That means z is going to be itself. We need to find y in terms of z, so we need to solve this equation in terms of z. So y, so that just means y equals 2z, simple as that. Now we just plug in this to our one and only 3-variable equation. I guess we could also use this 2-variable equation. Either way, doesn't matter. We have negative x minus 2y plus z equals -1. We don't know what x is, but we do know that y in terms of z is just 2z plus, and we know that z is itself, and all of that equals -1. So we have negative x minus 4z plus z equals -1. So negative x minus 3z equals -1. Negative x equals -1 plus 3z. And I'm running out of space here. This means let's divide everything by -1, so we have x equals 1 minus 3z. So this is x in terms of z. So we have x in terms of z, y in terms of z, and then of course z is in terms of z. So our answer is x, y, z equals x in terms of z, so 1 minus 3z, y in terms of z, so 2z, and z in terms of z, which is just z. That's my answer. All right, guys, that's all I have for systems of equations. Hopefully everything is making sense, and I will see y'all next time for applications of this stuff.